Hello guys, let us learn about combinations and permutations. So what is combination? When you talk about combination is the arrangement of items without considering the order of arrangement. That's what we call combination. The arrangement of items without considering the order, while permutation is the arrangement of items putting into consideration the order. So here, when you talk about combination, the order is not important. So here, the order is not important. The order is not important. But in permutation, the order is important. The order is important. I can give you an example. We can have an example here. You are told that Ken Limited. Now this is an organization. Ken Limited has 4 employees. Ken Limited has 4 employees. We have Anne, we have Brian, we have Kate, and David. These are the 4 employees. Then you are told, if the organization was to form a committee of 2 people, determine the number of the possible committees. Determine the number of the possible committees. So these are the 4 people that we have. Let's see. So the 4 committees here, I will say solution here. I'll say that let Anne be represented by A, Brian be represented by B, Kate be represented by C, then David be represented by D. So this means the committees that we can form are as follows. 1, we can form a committee of Anne and Brian. We can form a committee of Anne and Brian. We can form a committee of Anne and Kate. That is Anne and Kate. We can also form a committee of Anne and David. Anne and David. So these are the committees. Still, we can form another committee here. I can form a committee of Brian and Kate. Brian and Kate. I can also form another committee of Brian and David. Then I can also form another committee of Kate and David. Kate and David. So this, if you look at the number of committees that you can form, these are the committees you can form. In total, the committees you can form, you can see there are 6. Because here, we don't consider who starts. We don't consider whether it is Anne who starts or it is Brian who starts. In other words, I can't say that we have a committee of Brian and Ann because this is the same committee. We are not interested in their order. What we are interested is the committee must either have Ann or Brian. The order doesn't matter. So in this case, we can compute these 6 using combination. When we are using combination, we shall say that the number of people here, the number of people are 4. Ann, Brian, Kate, and David. They are 4. So we shall say it is 4 combination 2. 4 combination 2. And to get 4 combination 2, if you use your scientific calculator, you will get 6. 4 combination 2, you get 6. Using your scientific calculator, 4 combination 2, you get 6. Now, from here, you can also be told this. If the organization was to tell the employees to queue, how many how many possible queues of 2 people would be possible. So in this case, when you are queuing, or when they are queuing, it means the order is important. Here, the order is important. So in this case, we shall now go to permutations. In this case, the order is not important, so we go to combination. So this simply means that if they are to queue, let's assume the queue starts with Brian. Sorry, it starts with Ann. Ann is the first person. So the queue, we can now first Ann, then Ann is followed by Brian. We can also have Ann as the first person, then Ann is followed by Kate. We can also have Ann, then Ann is followed by David. This is when Ann is the first person. These are possible queue. We can also have Brian, now Brian, followed by Ann. We can also have Brian as the first person, followed by Kate. And we can also have Brian, followed by David. The other possible queue, if Kate is the first person in the queue, it means we can have Kate, followed by Ann. We can have Kate, followed by Brian. And we can have Kate, followed by David. If David is the first person in the queue, then it means we can have David, followed by Ann. Then we can have David, followed by Brian. We can have David, followed by Kate. These are the possible queues that you can have of 2 people in this organization. Therefore, if you count these possible queues, these are 12 queues that are possible. In other words, here the order is important because if it is Ann starting, he is being followed by Brian. If it is Brian starting, he is being followed by Ann. So this cannot be equal to this because these are different queues other than this. Unlike when you are talking about a committee, whereby if it is a committee of Ann and Brian, we are not interested with the order in which the committee is formed. The way they sit, that's not an issue. In a committee, we are interested with the components, not the order in which they are formed. So that simply means, in this case, we can use what we call permutation to get this. Permutations. So to use permutation, it is simple. We just say the total number of people in this are for Ann, Brian, Kate, and David. So it is for permutation. How many people are being chosen here? We are choosing 2 people. So for permutation 2. This, if you use your scientific calculator, If you use your scientific calculator to get 4 permutation 2, you will find that this is 12, which is actually this. If you use, for this question, if you use your scientific calculator to get the possible committees for combination 2, you get 6. So you can see when the order is mattering or when the order is important, we get 12 possible we get 12 possible Qs. When the order is not important, we get 6 possible combinations. And this is the main difference between combination and permutations. So let's do more examples so that you can see more examples of combination and more examples of permutations. I want us to do these 3 examples. So first, let me start with this one, then we can move to the other one. We are told that there are 68 senators in a certain country. How many 6-member committees are possible from the Senate? How many 6-member committees are possible from the Senate? So this simply means it is 68. Here, we are not interested in their order. We are not interested in their order in which the committees are formed. That means we are not interested with who starts in the committee. What we are only interested in is the membership, the certain members, but not in the order in which they form the 6-member committee. And since we are not interested in the order, automatically that tells you we are going to use combination. So we shall say out of 68, we want to pick or we want to select 6, a committee of 6. 68, combination 6. From the calculator, this will give you 109, 453, 344 committees. These are the possible committees that you can have in that country, because we are not interested in the order. Therefore, we are going to use combination. We can also have another example here where we are told Mr. Willis took 10 pictures. On a certain occasion, he selected 3 pictures to be hung in a row, determine the number of possible arrangements. You know one thing, that when we are hanging pictures in a row, here the order is important. The order is actually important because you hang pictures according to a certain order. So in this case, the possible arrangements, that tells you, for this question, you need to use permutations because the order is important. We are also interested in which, among the 3 pictures, which picture will start. Hence, the order is important. So what we shall, to do this, we just take 10 permutation 3. So we have 10 permutation 3. 10 permutation 3, and this gives you 720 arrangements. This gives you 720 arrangements. This gives you 720 arrangements. Let's do this one. We are told that a mathematics class has 10 ladies and 6 men. Determine the number of different 5-member discussion groups that can be formed to comprise of 3 men and 2 ladies. 3 men and 2 ladies. So I'll start here to do 3 men and 2 ladies. Now, remember, from a group of 6 men, we are picking 3. So, to pick this, we say from a group of 6, we pick or we select 3. So, you use 6 combination 3. In this case, just to mention is that the order is not important. In a group setting, when you're having a discussion group, it doesn't matter the way you sit. What matters is the composition of the members in that group. Hence, here we use combination. So we are picking 6 combination 3. That is, out of 6 men, we are only picking 3 men. For ladies, we want to pick 2. So out out of 10 ladies, we are picking 2. Since this is and, we use multiplication. So here we are out of 10 ladies, we are picking 2. So we can solve this using calculator. Using a scientific calculator, you can solve that. I will have 6 combination 3. This gives me 20. Then we have 10 combination 2. This is 45. If you multiply this is 900. So this means there are 900 groups that can be formed, possible groups that can be formed, that comprise of 3 men and 2 ladies. I can do B. B, we are told at least 3 ladies. At least 3 ladies. Now, recall that the ladies are 10. Recall that the ladies are 10, and we are forming a group of 5 members. We are forming a group of 5 members. So this means we can have this combination 1. This means we can have this combination. The team is 5. We can have 3 ladies. We said at least 3 ladies and 2 men. That is one possible way. Remember, it's a 5-member team. We can also have, we can't have less than 3 ladies. So now, this time we can also have 4 or 4 ladies and 1 man. Or we can also have, remember it's a 5-member team, we can also have 5 ladies and 0 man or 0 men. So in this case, we need to choose 3 ladies. So from 10 ladies, I choose 2 ladies, as well as I need to choose 2 men. In this scenario, I need to choose 2 men from a group of 6 men. So I have 6. I choose 2 men. That is my first possible combination. Since here we can have this or this or this, where we have or, we use a plus. Where we have 3 and, we use a multiplication. So this means that we can also have, we need to choose 4 ladies and 1 man. So out of 10 ladies, I choose 4. Out of 10 ladies, I choose 4. Out of 6 men, I choose 1. Then I have or, which means plus. Here I need to choose, from 10 ladies, I only need to choose 5. So here I have 5. Sorry, here I have 10 combination 5. Then I have multiplied by 6. I'm picking 0, combination 0. So these are the possible committees that we can form. So using a calculator, we can simplify this. So I have 10 combination 3. 10 combination 3, this is 120. Multiplied by 6 combination 2, this is 15. Then you have plus 10 combination 4, this is 210. Then we multiply by 6 combination 1, which you have 6. Then we have a 10 combination 5, which gives us 252. Then you multiply by 6 combination 0, which actually gives us 1. So we can solve this. We have 120 times 15, which is 1800. plus 210 times 6, which is 1260, plus 252. So when you add these three, you get 3312. These are the possible groups. These are the possible groups that you can form from B. So this is for B. Then for A, we have this. So let us do for C. So for C, we are told that at most 2 men. So we mean from these 5-member discussion groups, we don't need more than 5 men. That means we can have 2 men, and since the team is 5, we can have 2 men and 3 ladies. Or we can have, remember it's at most, maximum of 2 men, 1 man and 4 ladies. Or we can also have 0 man and 5 ladies. That is, we don't need more than 2 men. So it is either 2 men, 1 man, or 0 man. So to do this, we still do the same. From a group of 6 men, I need to choose 2. Remember, the order is not important, hence we use combination. So from a group of 6 men, I choose 2. Then I multiply by, for this first combination. From a group of 10 ladies, I'm choosing 3. So 10, combination 3. Then we have plus, because this is OR. From a group of 6, this time I'm choosing 1 man. And from a group of 10 ladies, I'm choosing 4 ladies. And I have plus. From a group of 6 men, I'm choosing none. Then you multiply this with, from a group of 10 ladies, I'm choosing 5. I'm choosing 5. So we can simplify this using our calculator. We can simplify this using the calculator. So this is 6 combination 2. So here we have 15 multiplied by 10 combination 3. Here we have 120. Then you have plus 6 combination 1. 6, we have a 6 combination 1. That is actually 6. Multiplied by 10 combination 4. That is 210. Plus 6 combination 0. This gives you 1. Multiplied by 10 combination 5. This gives you 252. So we can simplify this. 15 times 120. This gives you 1800. Plus 6 times 210. This gives you 1260. Plus 252. So here we have 1260 plus 1800 plus 252. Our answer is 3312. So these are the possible groups that we can have that will contain at most 2 men. At most 2 men. Thank you.